Hi, this is a video help for Chapter 5, Section 4. Okay, so before we start talking about electron configuration, we need to talk about what happens to these electrons when they get excited. So, as you know, an electron inhabits a particular orbital in an atom, and as this atom absorbs energy, the electrons are the ones that absorb that energy. And electrons, when they absorb energy, they jump, they get excited, they go to a higher energy level. So this electron here would jump to a higher energy level, like shown here in this picture. And this higher energy level is called when it's in this higher energy level, it's considered to be in an excited state, an unstable state. So nature, as you know, does not like to be in unstable environments. So this electron will eventually jump back down. They always go back down to their ground state. Okay, so uh, as it goes back down to this ground state, it releases the energy that it absorbed. So if I look over here, I can see this is Bohr's model here. The same diagram is in your book. You can see here I have various concentric circles here. The first one is my N1. Okay, this is my principal quantum number, principal energy level number 1. And then I have a principal energy level number 2. And then I have a 3. And then as you can see, I keep going out to 4, 5, 6, and then eventually 7. So these principal energy levels correspond with our periods in our periodic table. So here, go back. Here you'll see that I have period number 1, period number 2, or my N2, okay, and then I have my N3, and then of course my principal energy level number 4, okay. So these correspond directly with the periodic table. So if I have an electron that is inhabiting my principal energy level number 1, okay, and as I stated before, these electrons don't just stay there, they get excited. Okay, so this electron, as it gets excited, it jumps higher energy levels. Okay, but it doesn't just quite jump 1 to 2 immediately, or 2 to 3, 3 to 4, and then 4 to 5. There are actually sub-levels. There are minor, smaller levels in between these major levels that the electrons have to jump. So we'll see here, number 1, our first energy level actually only has one orbital. Okay, S will always have 1, P's will always have 3, and my D's will always have 5, and F's will always have 7. So my 7th level here will always have 7 sub-levels that my electron has to jump in order to get to the highest energy state. Okay, so going back to my N1 here. So as this electron jumps from N1 to N2, it's an excited state at N2, it always goes back down to its original ground state. And as it does that, it emits this ultraviolet color. Okay, so you'll notice here that all the electrons that inhabit N1, as they all jump, it doesn't matter what level. Okay, they can go from N1 to N2 to N3 to 4 to 5, 6, and even 7. And when they all come back down, they all emit the same energy, which is ultraviolet. Okay, and then here's my infrared series over here on the right, and all of these electrons start off at principal energy level number 3. So they'll jump from 3 to 4 to 5, 6, and then to 7, and when they all come back down to their principal ground state, they all emit infrared. Okay, but not all of them emit colors that we can't see. We have a small spectrum of energy waves that we actually can see, and these electrons are primarily found in principal energy level number 2. So when this electron jumps from 2, 3, 4, 5 to 6, and then it comes back down, it emits that nice purple color. Or from 2 to 3 to 4 to 5, it emits that blue color. Or from 2 to 3, comes back down, it emits a lower wavelength red. Okay? So as you can see, electrons, when they get excited, they like to jump energy level. So if I'm here at S and I'm going to get excited and I have energy that I'm absorbing, this electron has to jump from this S orbital to the 2s orbital, then to the 2p orbital, and if it's still absorbing more energy, it'll jump from a 2p to a 3s, 3p, 3d. Okay? But no matter how high it goes, if it ends up at a 3d level, okay, and we'll talk a little bit more detail what that is in the next video. If it ends at a 3D level, it always makes its way back down to its original ground state. And as it does that, it then emits a very specific wavelength. Okay, and that wavelength we see as a color. Okay, so the energy that's being emitted by these electrons as they go back down to their ground state, we see that emission of energy as color. Okay, and as we noted before, not all color is visible to the human eye. Okay, some of them have too high of a frequency, too high of a wavelength, or too low of a wavelength for us to absorb with the unaided eye. Okay, so I hope this was helpful. Don't worry if it wasn't. Just keep reading, keep watching this video, and I have more videos to come to help explain this chapter. Okay.